So welcome back to Module 7 of CSC-120, Computing Fundamentals at RCCC. Module 7 is on Object-Oriented Programming. This is part 2 of our lecture on Object-Oriented Programming. So hopefully you have taken in the part 1, which was about an hour long, and we stopped, and so this video is picking up where we left off in the last video. I hope you took a break. I know I did. So let's take a look at my blackboard. Okay, so this is the material that was covered in part 1 of the video. I have it highlighted here, and I'll check to make sure that, yeah, good. Making sure that I had the desktop shared. So we left off with instantiating objects from a class in Python. Here's the textual material, or I guess you could say textual and graphics. So we took a circle class definition. Remember, a class definition is the pattern that we use to create an object. So right here is a line of code that imports circle.py. The circle.py file has to be in the folder where your this program would be located. So I'll flip over to Tani for a moment so you can see what we had open when we left off in the last video. So here's some code that we wrote to import the circle.py. Circle.py here has the class definition for a circle class in it. You'll notice here as a review, what I have highlighted here in gray is the constructor. The constructor has one default parameter. When I say default, you could say it's optional because if we don't supply a parameter when we create this this object of a circle class, then it'll automatically assign 1 to radius. Okay, so this is the constructor that we talked about in part 1 of the lecture. These are getter methods. I usually name my getter methods with get, just so that it's pretty plain. Another name for a getter method is an accessor method. So we have 2 accessor methods here in our circle class definition. We have one mutator method, and another name for a mutator is a setter method. Okay. Now, every method of a class has to get past a reference to the object instance. And you can see that I used self. You could use any name. Python's going to make whatever the first thing you send to this method the instance of the object. So self is just what most Python programmers use for that instance of the object. You could use anything as long as it's a legal variable name. You could use that, okay? But you can see every single method of my class has the first parameter as self, okay? When you actually are passing something to the method, then you would have more than one parameter, obviously, here, because self's going to be the first one, and then radius is there. Okay? Now, just to remind you, this constructor gets called when we instantiate the class which is right here when we instantiate an object from that class. Here I'm making an object named small circle. This line right here calls the constructor for the circle class definition. And you notice I don't have self inside the parentheses there. When you're outside of the class definition, you don't pass self to the object. You only pass self when you're in the class definition here. Okay? So make sure you keep that straight. But here we're passing a 1 to it. That's going to come in as the second parameter to our constructor right here. Okay? That 1's going to come in. It's going to get stuffed into this parameter named radius, and then it's going to get set to a public property for our class that's called radius. Okay? So once you do this self.radius, every method that has a reference to self would be able to get to self.radius. Okay? So there are actually two ways we could set the radius in our circle. If you remember when we ran this, we got the area 3.1415, the area of the circle. I could change that. I could change that radius using the mutator method or the setter method. I think it was called set radius right here. See it? So if I wanted to change that once my object's created, I could just do this. Small circle dot set radius, and we could make it 100. Okay, so we could make it a lot bigger. Now that should change our area a good bit. Let's just try it, and let's see what happens when we run that. The area of a small circle is now 31,415. You can see it just moved the decimal over quite a few places there. Okay, so you can see that the area got a lot bigger. So actually two ways I could set the radius. One way is through the constructor, because we provided ourselves a way to do it there in the constructor. Another way was using this mutator or this accessor method right here. Excuse me, not accessor, a setter method. So a mutator or a setter method. Okay, so I called the set radius after my circle was created here. So right here's where I called it. The circle got created with a radius of 1, and then I changed the radius. Okay, now right now the radius is a public property that we could actually get to. This is not recommended the way this is done, but remember, we're just getting started with classes and objects, so we didn't want to interject too much complicated stuff in here. We kind of ease you into the object-oriented programming. So I could actually get to that radius property because it's public unless you do something different. I'll just write some text out here, and then small circle dot radius. Now that is not a method, it is just a property. So you notice I don't have the parentheses on the end of it to run it, because I can't run that. That is actually a float. I wouldn't be able to run it if I put parentheses on the end of it. So I'm just showing you here that we can get to the public property here. Public property for radius. So when I run this, I'll clear it. We should still have a really big, see, we got a really big area here, and there's where we change the radius to 100. Right here's where we printed it out with this line. Okay, so that's instantiating objects from a class definition. Okay, so you've learned when the constructor gets run. You've learned how to pass things to the constructor. And we've learned about public properties. I'm going to move on to some new material now. Right here, accessing members of objects. Now we've done some of this already. Okay, so right here it says an object's members refer to its properties. Another name for properties are data fields. And methods, if you recall, methods are those things that cause something to happen. And you remember when we're creating a class definition, our methods are really deffed, aren't they? They're just deffed out like functions. If you go back here and look at our class definition for a circle, you can see we've got def, 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 def. Okay, these are all methods here. Okay, so, all right. Properties are also called instance variables. That's because we could have more than one circle, as this code is going to do. We're going to, with this one, we're going to have a small circle and a regular circle. We can create those right here. We're creating one from the circle class definition. So here's some code to actually do that. I can just take this code and copy it. Of course, you could download it right there, but I'm going to just copy it and paste it into Tawny here. Okay. Remember, this is going to have to be in the same spot as our circle.py. Let's see what they named it here. They named it createCircleObjects.py. So that's what we'll name it, just so we're doing something you can follow here. If I try to run it, then this is where I get to name it. Was it dashes or was it underscores? Does anybody remember? It was dashes, so we'll stay with the dashes. Okay. See if I can find my little window here. I may have to start over. Let's see. I'm missing my little dialogue, as sometimes happens when you minimize Windows. Here it is. Create circle objects. Okay, I got that done, and you can see here, here's where it ran, and it what did it do? It created 3 different instances of a circle class. They were named small circle, regular circle, and big circle. Small had a radius of a 1, regular had a radius of 25, and a big had a radius of 125. And here's just showing you the whole point of this code, just to show you that each instance has its own data, doesn't it? Each instance of our circle class here, one was named small circle. It had its own data of radius of 1. Regular circle had its own data, radius of 25. Big circle had its own data, radius of 125. So that was really kind of the whole point of that code, was just to show you that each of those objects that we brought into existence had its own data. Okay? And so we can get to those methods that or properties for that matter, if they're public. We can get to those things by using the dot operator. And that's what this text is telling you right here. Once we've created a small circle, if we wanted to get to the to print the radius out, we could use the accessor method for a circle that's called getRadius. And so we would say small circle dot getRadius. Now here they're using the accessor method to get the perimeter. Okay? Get the perimeter. Remember that we're calling a method, so we've got the 2 parentheses on the end of the method name. Okay? So when you use that dot, behind the scenes, what Python has to do is it's got to dereference the object. It's got to go out there and find where that object is in memory, and it's got to figure out where this getPerimeter method is. And so that's why we call it dereferencing, because when you put a dot here, that tells Python to go out and look for that method. And that process is called dereferencing. And if you've got a lot of methods and a lot of data in the object, it could be real time consuming. In the CSC-121 graphical Python class, I show students how to store a dereferenced method in a variable so that you don't have to incur all that performance hit, make all that extra work for the computer that comes from this dereferencing process. We could store something like this in a variable, and then it's already what you would say pre-dereferenced. So you only do that dereferencing once, instead of here we're doing it 3 times. So show you some ways to speed things up in the next Python class. So all right, so looks like we're ready to move on to the next part of this material on objects. So we're down here to this constructor and destructor walkthrough. Now you'll notice that there's not a link to that. That's because this is in Blackboard and I can't really link to it. Okay, but I can click into it. Now here's a video that I did for the CSC-121 class. You can see in 2020. So you can watch this and it will explain to you when the constructor is run, which we've already pretty much covered that, when the constructor runs. We haven't really talked about when the destructor runs. And so I've given you some code here that creates a little an employee class, and I've actually written a destructor for it. Okay, a destructor. So the constructor and the destructor are optional. You could create a class and leave both of these things out. Okay, and so far we have been leaving the destructor out. If there's something that you want to do when your object is destroyed to clean up afterwards, then you can put code in this destructor method that's named _del_. This gets run when you delete your object. Okay, so I'll take this code, it's right here, and I'm going to save it down into our folder that we've been working out of, CSC-120 Module 7. It's named whenconstructdestructorrun. Okay, so let's open that up in Tawny and let's talk about it some more. Okay, so here's the code. Now, right here, this is our class definition. Now, I don't make you do this in this CSC-120 class, but every program that we write in the next Python class, the CSC-121 class, I have students add this code at the bottom. Now, this code is actually doing what? It's creating an object. The object's name is actually OBJ. It's an employee. It's an employee. Okay? Now, just so you understand what this code is doing, is this only runs, this code right here at the bottom that's in this if statement only gets run if we're running this program from itself. If this code right here were inside this circle.py, remember we're importing circle.py here. Okay? We wouldn't want code to run that's in this circle.py class definition. So what this code right here does is it keeps this from running. This will not happen if we import this file when construct and destructor run. So it basically lets you take and have some little code at the bottom of your class definition files that lets you test it out. But this code never gets run if you import this file into another program. You getting me? This code that's in gray highlight never gets run if this file is imported into another Python program. Okay, so now that you know why this is there, we can go ahead and talk about what's happening here. Nothing special with this constructor. It's just printing employee created. Nothing special happening in the destructor either. It's just printing a message that tells us when it got called. So right now, if we run this code, the only thing that should happen is we should get a message that says the employee is created. Let's clear this out and run it. You see, all I got was the employees created because we never deleted our OBJ variable, did we? It never got deleted. Theoretically, it's still out there taking up memory until we close Tawny. So if we wanted to get rid of it to destroy our object that we just created, remember it's named OBJ in this case, I show you two ways that you could get rid of it. One is right here. You can say del, and this is going to destroy that object. So when we run this, it's going to go up here and find the destructor, and it's going to do everything that's in the destructor. So when I clear this out and run it, you can see destructor called, employee was deleted. Okay, actually it should say obj is deleted, huh? but it doesn't know inside the object what the name of the inside the class what the name of the actual object is. Okay, so it just said destructor called. Okay, so that's one way that you could do it. The other way, there's a special variable in Python, or a special literal actually, that's called none. If you set an object variable to none, it automatically calls the destructor here. So gonna clear that code out and run it again. You can see both of these things did the same thing. They called the destructor. When would you use this? Think if you had a Python program that was accessing a database. To access a database, you've got to connect to the database. So we could potentially put our connection code inside our constructor that got us connected to the database. Okay? At the end, when you're done using a database, you have to close our connection to the database. So you could put your code to close the connection here. We've written some programs in this class. In CSC-120, we've written some programs that used files. If you remember, we had to open a file. We could put our open in our constructor. We could put our close in our destructor, and Python would take care of that. When we opened up our object, when we created our object, it would automatically open the file. When we deleted our object, it would automatically close the file. So I'm just giving you some examples of where you might use the destructor and the constructor. Okay, you do stuff that you want to happen at the start of the program in the constructor. You do stuff that you want to happen at the end of the program in the destructor. Just remember, the destructor may not get called when you think it's going to get called unless you explicitly destroy your object by setting it to none or calling a delete. Okay? Now, in this code where we were doing circles here, and we had small circle, and we were doing this stuff, if we wanted to actually, now there is no destructor coded here, so it really wouldn't make any sense to call delete against small circle or set small circle equal to none, because there's no destructor in here anyway. Okay, but if there was, and you wanted it to automatically run, then you would need to call a delete against a small circle at the end of the program. We could do that, and you'll see it doesn't make any difference. Python goes ahead and creates what it calls a default destructor anyway. Okay, so I'm getting rid of that. You can see when I run it, you can see nothing special happened because there wasn't any code in the destructor. Okay, so we've talked about when the constructor and the destructor are run. Okay, so now you know what a destructor is. It runs when you get rid of your object. We've got one last topic to talk about, and this is probably some of the more important things to understand, and that's encapsulation. encapsulation. Why is it so important? When we first started talking about objects and object-oriented programming, I think I showed you with the W3 Schools material. This is in part 1 of the lecture. I showed you how the little X variable that they were using, we could make it a private variable. Okay? Now, encapsulation helps to hide the details. It's also known as data hiding. Okay? It makes your program easier to understand, but it also serves another important thing. It makes it more reliable, because if you're doing object-oriented programming right, if we were doing this object-oriented programming stuff correctly, nobody would ever be able to get to the radius except through a getter method that we provided. The rule is you don't let people get to your data except through methods that you create. Remember, an accessor method lets us get that stuff. Okay? So, you can see right here, encapsulation helps to prevent accidental modification of the data. Somebody could be writing a big program and they get a hold of one of our public variables or public properties of our object accidentally. We don't want that to happen by accident. So if we make all of our data private, then they can't get to it very easily. There is some backdoor ways of getting to stuff, but I talked to students about that in the CSC-121 class. So, and we talked briefly about it here. Okay, so you can read about encapsulation at Wikipedia. I linked it so that you could understand what it's talking about here. Not only can we make, and here it also, see right here, it talks about getters and setters. Okay? Getters and setters. Remember, another name for a getter is a mutator. Okay? Another name for a setter is an accessor. Okay? So, you can read that later. Okay? So, we can make variables or properties private. We can make them private. We can make our methods private too. So you heard me say that. Our methods could be private. If you want to write a method in your class definition and you don't want people on the outside world to get to it, then you can make it private and people outside of your class can't get to it very easily. Okay? So, here a class definition encapsulates all of our properties, that is our data fields, okay? And behaviors, that is our methods, okay? And unless we make them private while they're encapsulated or bundled up as part of our class, okay, that doesn't mean that they're protected. So we're going to figure out how to make those things protected. And I gave you a preview of that in part 1. Okay? So this is just going ahead and telling you one more time. This will make the 3rd time that I have told you this. Unless you do something special, your properties and your methods are going to be public. That means that folks outside of your class definition can get to them. That may or may not be a good thing. Okay? The good rule of thumb is only allow folks to get to what they need, just what they need. Limit their access to just what they need. Okay? So, some languages use public, private, and protected keywords. We don't do that in Python. There's no public keyword in Python. If we just name a property with a regular identifier, then it's public. Okay? Some folks will try to tell you that Python has protected access. It does not. It does not. Basically, what these folks are preaching out there is that if you're going to allow folks that use your class definition in their program to inherit your class and add things to it, then you can name the properties or the methods with a single underscore that are supposed to be used in programs that inherit it. But that's just by agreement. Python does not enforce that. There is no protected access in Python. Okay? Here, the next one, private access, is what I demonstrated to you briefly at the start of our lecture in part 1. If you name a property or a method with 2 underscores as the first 2 characters of its name, then Python makes it private. Again, 2 underscores in front makes it private. Now I want to give you a caveat on this, what I just told you. Okay? There are some special methods that come built into Python. We've been using one already. Actually, we've been using 2. But if you remember, what does a constructor have as the first 2 letters of its name? It has 2 underscores. Remember, the constructor is double underscore, init, double underscore. Well, guess what? Even though its name starts with these 2 underscores, it's not private. We can call the constructor again. We can call that constructor method again. I'll go back here and just show you right here in this example from when the constructor and destructor are run. Right here's our constructor, right? When we had this example and we ran it, you can see here's the employees getting created, and here's where we deleted the employee. I'm going to comment this out. Okay? Alright, so now when I run it, you see I'm just getting this print from the constructor of our employee class. Okay? But watch what I can do right here. obj dot double underscore init. There's no parameters that are getting passed to that. Okay? And I can call it. Remember to call it, you put the 2 parentheses on the end of it. So here goes. Whoops. Let's see what I did wrong here. Oh, I put an extra set of parentheses right there. See what happened? Here, I called the constructor. I'm outside of my class. So even though this thing starts with 2 underscores, I can still get to it. Okay? I can still get to it. Let's make ourselves a private method here. Double secret SECRET, double secret probation. We'll put somebody on double secret probation. How's that? All right. We're going to make ourselves a private method here. Okay. I'm putting the two underscores and double secret. Okay. Self print this employee is on double secret probation. Okay. So we have created, let's see, I gotta get my quotes to match up here. Okay. This employee now has a double secret probation method. Okay. So out here, if I try to call that method, obj dot double underscore double secret. Let's try calling it. Okay. Here goes. What's it say? Employee object has no attribute named double underscore double secret. Well, actually it does, but we made it private. We made it private. Now, just to prove to you that we can get to this method here inside of our class, okay? Inside of our class, okay? I'll go ahead and put a call to that method down here, self dot double underscore double, okay? Call the private method. So you can see, why did I have to put self? Because this method is part of our class. You can only get to it if you reference it through self. Self is an instance of our object. So I had to say self dot double underscore double secret. Now I'm going to go ahead and down here I'll make my constructor run. Okay. I'll have to comment this out or we'll still get an error in our program. You saw we couldn't run it there. Okay. So we can run this from inside of our class. Remember, this is our class definition. Everything that's in here, even inside here, inside of our class, we can get to our private method here. Okay. So here goes. When we call the del. Now remember, I'm calling the constructor here, so twice. So I'm going to see employee created. Well, that could get confusing. Let me just comment that out. Okay, so we should see employee created. Then we should see that they're on double secret probation, and then we should see the destructor was called. So here goes. You see? Right there it is. So I just showed you that we can make something private, even a method. Okay? So this goes to what I was talking about right here, about how to deal with private data the right way. But before we get into that, just so that you know, the way that Python protects, and I put that in parentheses, protects your private data and your private methods is by name mangling. Name mangling. So when you put double underscores in front of something in Python, it mangles that name. But we can still, somebody that knows what they're doing can still get to it. It's just a lot harder, and it's going to keep most people from messing with it. So somebody's going to have to really work at it in order to get to something. Okay? But it name mangles it, and I can show you the mangling here if we go back to our employee program here. And I'm going to do a dir. Actually, I'll do a print. And I'll put the dir inside there. Dir lets you look at the namespace. And I'm going to do a dir on obj. Okay? That's our employee object that we got created. This will show us everything that we can get to. Okay? So here goes. Right here is my dir. This is my dir right here. And look what I've got. First thing. You see that? Underscore employee double underscore double secret. That is how we could get to that method if we wanted to call it. If we wanted to call it, we could get to it that way, a sneaky way, because it's mangled the name. If you look through this stuff, you can see there's nothing else that we could get to, is there? Everything else is pretty much private. You can see we could get to the destructor. We could get to the constructor here. But that's really pretty much it. We can't get to this method except by sneaking around and looking for what it mangled its name to. So this is our name mangling that took place. Python trying to protect us, but it didn't protect us. It didn't protect this double secret probation from the super sleuths that we are, right? You're all secret agents now. You know how to get into double secret stuff. Okay? So just to tell you, if you want to try it out, you could get to it by obj dot underscore capital E and so on. This method right here. Remember, if you wanted to get to it, you'd have to put the parentheses on the end of it. So that's the name that it right here. This is what it mangled it to. Okay? Python's quote protection. Don't count on that in a life or death matter, right? You'd probably want to encrypt rather than trust in that name mangling that you saw how easy it was to get around that. Okay, so dealing with private data, here is an example of how to deal with private data. First, I'm going to save this down so we don't have to key all that stuff in. Now, one thing, we listed a lot of advantages. We listed a lot of advantages of object-oriented programming, but short code or briefness is not one of them. Okay? In order to implement all this protection and inheritance and encapsulation and all those good things that we get from object-oriented programming, you have to write more code. You have to write more code. And so you can see here what I have in orange. If we want to do this right and make radius private, right here is where radius is private. See, it's double underscore radius. If we make this private and we want people to be able to change the radius and we want people to be able to print out the radius, then that means that we have to create a mutator method or a setter method that lets people get to it. We have to create a public setter method, a public accessor method or getter method here that lets people print it. So you have to control or write code to control how people get to this. If we didn't have these two methods right here, then folks would not be able to get to self.double underscore radius at all. They would not be able to get to it. Okay, so let me go ahead and save this down. Circle private, I'd already saved it. Okay, here's the code to try it out. So, gonna copy that, and I'll go back to Python here and create myself some new code here. Okay, and you notice that we're importing circle.private. Let me just close some of these things so that we don't have a whole lot open. Okay, let's take a look at circle.private or circle underscore private. Okay, here's that code that we were just looking at in Blackboard. Okay, and you can see here's our private radius property. Okay, private. So we've got this setter method. Excuse me. This is the setter method. This is the getter method right here. Okay. So if we go back to our code here, you can see this line's going to blow. I just showed you that earlier. If you have something that is prefixed with the double underscores, it's quote private in Python. So let me go ahead and save this. I'll call this circle private test. Circle private test. You can see that I'm getting a traceback error here in red that says the circle object has no attribute underscore radius. That's because we made it private right here. Remember, Python name mangled it. Probably it mangled it to underscore circle double underscore radius is probably what it mangled its name to. But anyways, it's quote private. So the only way we're going to be able to get to the radius is through our getter method here that we wrote that's called getRadius. Okay? Here's that getter method to get it. Okay? Right here, because it's a method, we had to put the parentheses on the end of it to actually run it. So let's try this code out. Now you can see I'm still getting the traceback error because I have this line going on. So I'm going to comment that out. Okay. And I'm going to run it again. And there it is coming back through the getter method. Okay. So what can you do with this in the real world? Well, we already talked about this. We don't want folks to get to our private data, so that's protected now. Okay? What else could you do with it? Nobody can change your radius except by going through this method. So you could write some code in here that prevented radius from ever getting set to a negative number. We would want to protect radius, wouldn't we? There's no such thing as a negative radius for a circle. So inside of our setter method, we should prevent bad things like that. So do you remember the function for Python that we could tell if something was a number or not? I think it's isNumeric. So we could actually let's test that out for a second. Print. Let's make ourselves a radius here. Okay. Print radius dot is numeric. Let's try that, see what it says when we run this. Is numeric. Test. Okay. Let's go look at our strings lecture and see what that is. RCCC IT. Okay. And then string methods right here. And let's try it out. Is digit. Is digit. We'll need to look and see if there's a method. I was thinking there might be a method to check to see if something was a valid number or not, but I think we would have to write some code. But that would probably be something that we would want to do in our program for our right here for our setter method. Okay, but let's go back and just try to prevent this from ever being a negative number. We could do this if radius, and remember this is a parameter, so I don't have to put self.radius because this is a parameter that was supplied to us. If radius is less than 0, okay, print invalid radius. Okay, and then I could return. Okay, and then if I don't get if I do the return right here, okay, it's never going to run this line. So that should be everything we need to prevent the radius from being set to a negative number. So we've added some code here to try to prevent folks from doing bad things with our radius. Okay, you can see, let's see, I need to save that. Okay, I've got that saved now. The asterisk went away. So, all right, let's run that again. Okay, so let's try setting the radius to a negative number and see what happens. Regular circle dot set radius minus 1.1. Okay, let's see what happens now. It said invalid radius, and it kept the radius at 25. So can you see how we could prevent bad things from happening? We didn't let folks get to our private data for radius here, but because we forced them to use our setter method, we could do some validation. We could do some validation and print out an error message and not set the radius. Why did this keep them from setting the radius to a negative number? Because when we had a negative number here for the radius, it printed invalid radius and then it returned. If you remember, whenever you hit a return in a function or a method, it ends right here. So this was the end of that. It never did this line, and that's why it kept our 25. Now, let's go back and run it again, but this time let's set it to 100. And it should take that because that's not a negative number. So, and you can see it did. So just showing you the concept of using your setters or your accessors to validate data validation, to keep bad things from getting put in our private data for our class. Okay, so I think that's the end of it. So that's the end of both parts of our object-oriented programming lecture. Now, you will have some homework questions on this material. You'll also have a project to write. So I'm going to do a short video to get you up started with Project 10 that creates some objects and lets you kick the tires on object-oriented programming. Thanks for watching, and I hope you're able to use this object-oriented programming stuff in the real world at some point. Take care.